In the next problem, the question says, what is the total cost of 1.2 cubic yards, which is the same as yards cubed, of soil if it sells for $24 per cubic pound? Notice the word per. Per is division. So we have two pieces of information. One is 1.2 cubic yards, so yards cubed, and the other information is $24 per 1 cubic yard. So 1.2 cubic yards times $24 over 1 cubic yard. Now, why do we do this multiplication? The question says, what is the total cost? Okay, so the cost has units, which is dollars. So in this fraction, dollars per cubic yard, if we could somehow get rid of the cubic yards, then our final answer will be in dollars. So that could happen only if we multiplied these two together. That would cancel off the cubic yards, and if we combined the numbers, that would be the cost of 1.2 cubic yards. So 1.2 cubic yards times $24 over 1 cubic yard cancels off the cubic yards, and the dollar sign survives. So that is our final unit, and that's exactly what we want. We want it to be in the numerator, and that's where it is. We combine the numbers, 1.2 times 24, to get $28.8. So we are using the technique of dimensional analysis to solve problems. Here we are not doing conversion of units. We are solving the problem of finding the total cost by using the same technique as we did in conversion of units. Let's look at the next problem. Now, we read the question carefully. In 2008, about 310,000 Americans died of sudden cardiac death, and that happens to be about half of all deaths from coronary heart disease. Okay, so assuming that the population of 305 million, the question says, what was the mortality rate in units of deaths per 100,000 people? So let's say we want to calculate that for coronary heart disease. So coronary heart disease, we want to find the number of deaths per 100,000 people. So about half the deaths are caused due to sudden cardiac arrest. Okay, so which means that the total number of deaths due to coronary heart disease is twice that amount. So coronary heart disease deaths is equal to 2 times 310,000, which is equal to 620,000. That's the total number of deaths due to coronary heart disease. The mortality rate is the number of deaths over the total number of people. So 620,000 deaths out of 305 million people. So 305 followed by 6 zeros. But we want to find the number of deaths per, which means divided by 100,000 people. So we write our denominator as 3050 times 100,000. Combine the two numbers, 620,000 divided by 3050, so that is 203.28 deaths per, and what's left in the denominator is 100,000 people, so it's 203.28 deaths per 100,000 people, and that is our deaths due to coronary heart disease. The next problem gives us some information. A human heart beats about 70 times per minute. So in 1 minute, the human heart beats about 70 times. If an average human being lives to the age of 80, how many times does the average heart beat in a lifetime? So we need to calculate how many minutes are in a lifetime. So if we can figure out the number of minutes in a lifetime, we just multiply that by 70, because every minute the heart beats 70 times, and by multiplying with 70, we get the total number of times that the heart beats in a lifetime. So the first question to answer is, how many minutes are in 80 years? So we start off with our basic calculation. 60 minutes in 1 hour. There are 24 hours in a day. So this calculation, 60 times 24, gives us the number of minutes in a day. 24 hours in a day, each hour is 60 minutes. 60 times 24 is the number of minutes in a day. Our next step. So now we at least know how many minutes are in 1 day. Our next step is a little bigger. We want to find out the number of minutes in 1 year. So let's go to the next step, which is, how many days do we have in 1 year? Let's just assume it's 365 days in 1 year. So in 1 day, there are 1,440 minutes. And in 1 year, we have 365 days. So 365 times 1,440 minutes in 1 year. And that is equal to 525,600 minutes in 1 year. So we know that in 1 year, we have 525,600 minutes. So now we come to the last step, which is in a lifetime. How many minutes are there, assuming that a lifetime is about 80 years? So in 1 year, we have 525,600 minutes. So in 80 years, it would be 525,600 times 80. And that's the total number of minutes in 1 year. I'm sorry, in not 1 year, but in 80 years. So in 80 years, this huge number is the total number of minutes. Okay, I'm sorry, the comma should be here. So 42,048,000 minutes in 80 years. So in 1 minute, just in 1 minute, the heart beats 70 times, right? So there are 70 beats in 1 minute. So in 42,048,000 minutes, it's going to beat 42,048,000 times 70. So that's the total number of beats in a lifetime. So initially the problem seems kind of impossible to solve, but if we go step by step, going from one basic step to another, we can build the problem and arrive at a final answer. The next problem. Suppose the car averages 32 miles per gallon. There's our rate, 32 miles per gallon. If the average speed is 60 miles per hour. So that's the first piece of information. If it averages 25 miles per gallon, it averages 25 miles per gallon if the car's average speed is about 75 miles per hour. So the number of miles that the car would go per gallon depends on the speed. If the speed is higher, then the mileage, the number of miles per gallon reduces. So let's try to answer the questions. Looking at part A. What is the driving time for 1500-mile trip? Okay, so we're going 1500 miles and our average speed is 60 miles per hour. So we need to figure out the time that it takes if we go at a speed of 60 miles per hour. So our final answer has units in hours. So if we take this fraction and if we could somehow make sure that the hours is in the numerator and we somehow cancel off the miles, then we get our answer in hours. So the only way to make the hours in the numerator is to flip that fraction. So going 60 miles in 1 hour is the same as saying in 1 hour we go 60 miles. So that's flipping the fraction. 1 hour over 60 miles. And the reason why we flipped this was so we could get hours in the numerator. Now the number of miles we're going is 1500. So if we multiply this fraction with 1500, what we get is the cancellation of miles. That's exactly what we wanted. The hours survives in the numerator, and that's how our final answer has units in hours. Combining the numbers, 1500 divided by 60, we have 1500 over 60 hours, which is the same as 25 hours. Now we can repeat the exact same process because the next question says, what is the driving time at 75 miles per hour? So we have 75 miles per hour and we need to figure out how much time it takes. So our units for the final answer should be hours. So the fraction that we have here, we need to make sure that the hours is in the numerator because we want our final units to be hours. So the only way we can do that is by flipping that fraction. By flipping the fraction, we have 1 hour over 75 miles. Now we need to somehow cancel the miles off. Since it's a 1500-mile trip, we multiply this fraction with 1500. We get rid of the miles, and that's exactly what we wanted. The units in the numerator is hours, and that becomes the unit for our final answer. We combine the numbers, 1500 in the numerator divided by 75 in the denominator, which gives us 20, and the units, which is hours. Now we look at the next problem. We're given the price of gas per gallon, $2.90 per gallon. What is the gasoline cost? So now we need to figure out the dollar amount that we spend on a 1500-mile trip. And what is our average speed? 60 miles per hour. We need to know the average speed because the miles we get per gallon depends on the speed at which we travel. So the question is, how much does it cost? If we could first figure out how many gallons we consume when we go on a 1500-mile trip, once we get the number of gallons, all we have to do is multiply it with, so gallons times the dollar amount per gallon, which is 2.9. That would give us the total cost of our trip. So our step one is to figure out how many gallons. So the information that we have is 32 miles per 1 gallon, and we're going at 60 miles per hour. So we need to get gallons in the numerator. That's the reason why we flip this fraction. It's 1 gallon over 32 miles. We multiply it with miles. Our 1500 mile trip has miles as the unit. We multiply it, so that cancels off the miles with the miles. And we're left with gallons in the numerator, and that gives us the unit for our final answer. We combine the numbers, 1500 divided by 32, and we get 46.875 gallons. So now that we know how many gallons were bought in the 1500 mile trip, we need to now figure out the dollar amount by multiplying the number of gallons with the dollar amount. So 46.875 gallons times $2.90 per, so divided by 1 gallon. So the gallons get cancelled. So basically we multiply these two numbers to get the dollar amount, and that is $135 and about 94 cents. So that's the total cost of the 1500 mile trip if we went 60 miles per hour.